Hello and welcome to the first lesson of grade 11 college math. We're going to start with the, hopefully you find nice easy review of Pythagorean Theorem. I'll show you here the assigned works on the top page of the lessons as always. So there's just the 5 questions there that we'll do submit. And it's on the Pythagorean Theorem. So I'm just going to show you some of the things that hopefully you've seen. One big thing I want you to recognize is that we don't have to anchor ourselves to size A, B, and C. There's nothing special about those letters, okay? So you're going to see in my formula for the Pythagorean theorem doesn't really involve any B and C. It's maybe a little different than what you've seen. And because I don't want you to get confused with trying to translate from, in this case, the R to the C, nonsense like that. It's just too confusing. And so the other thing that I'm going to show you but the property we're talking about, of course, is these areas, right? And so this area and that area, and the idea that they combine, add up to be this one, right? So that one plus that one or whatever is there. So something that I've done in my classes you might have seen is you can start out with squares that are 3, 4, 5, and 6, 8, 10, or they can be 3, 7, 5, and 7, meaning that you would actually take like this graph paper and cut out a square that's 3 by 3 and a square that's 5 by 5 and so on. And you put the squares corner to corner to make a triangle in the middle. And then you look and you analyze and you think, okay, well, were they a right triangle or not? And it turns out, of course, that all of the ones that are right triangles, so right angle, right angle, right angle, right angle, and so on, all of those have a particular math property where you look at the areas of the 2 little squares that have the possibility of adding up to the big square, right? And so really in the class, we didn't know that they added up and so on, and the students had to kind of figure that out back in grade 10. So you might have seen something like that. This really drives home the idea that you have areas that add up, the smaller areas add up to the bigger areas, right? And so pretty clearly, it's kind of funny to think of someone thinking that, maybe this area here and this area might add to be this one. Clearly that can't, because it's way smaller than the rest of them, right? So it's going to be very important that the biggest square goes in a spot that would represent the little ones adding up to it. And so I just want to clear a couple things here for you so you can see what I want to show as well. And it's going to be another slide coming up, but this longest side, of course, is your longest square, and that's the special side we call the hypotenuse. So the hypotenuse is that special side. And sometimes you can really easily tell it's the longest, but otherwise maybe sometimes it's easier just to think of it as opposite that right angle. So now we've pictured, discovering the Pythagorean theorem and so on ourselves and seeing the number pattern and so on. I think this is the page from when I had done it with the class, you notice, hey, look, those smaller squares add up to the larger square. And if they do, then it's a 90 degree. If they don't, it's not a 90. So this is where the formula kicks in, where I want you to really think of this one as the hypotenuse. You might start saying H1P for short, right? That's the special side across from the 90 degree. Really what you have to do is you have to make sure that that side, whether it's a number or a letter, it doesn't matter, that side has to go here, right? The hypotenuse has to go there because it's the big square. So you've got the little squares on the left side adding up to the big square, right? So I really recommend you think of this as your formula for Pythagorean theorem. Literally just blank spaces for sides squared that add up to another side squared. And you can just fill things in nice and easily, and I'll show you how that would work, right? So for this example, and you're welcome to pause the video, of course, and try it, and then press play and see if I do the same thing as you do. But I would definitely look at this and say, hey, it's a 90 degree triangle. And so, wait a minute, that's my hypotenuse right there. And so I'm going to pull out my formula. It's kind of a fill in the blank or Pythagorean theorem. And this hypotenuse has to go right there, right? So we're going to have E side that we're looking for. E that, notice we didn't have to translate from like, oh, in this case, the C is an E and so on. That'd just be kind of silly, confusing to do. So the 6 and the 2 can just go in the other spots. It doesn't matter which order. And then I like to think of this as like the Nike symbol, right? Where it's like, what do I do now? You just do it, right? You've got this 2 squared, so you do that, you get 4, the 6 squared, you can get 36. You have your e squared equals those. So then e squared equals the 40. And then to grab a calculator to get rid of the square, I'm going to be doing square root both sides. I also think of this as plus or minus, but it's Pythagorean Theorem, so it's just minus of sides. I know it's just going to be positive. But root of 40 is 6.32. So 6.3, 6.32, whatever. That's what E is, right? Of course, it's a triangle, right? You could say therefore, the side length and so on, but it's pretty obvious in the case communication-wise that E is your length of the event. Okay, so number 1 there, we're missing the hypotenuse. There's another one where you're missing the hypotenuse, same kind of work. Move ahead to another one missing the hypotenuse. So the main thing here is to see like the other type of case for your solving. And so if you identify here, there's your hypotenuse, and that you have a 90-degree triangle, you're going to do the same as before. Again, pause and try to play it max. I'm not going to wait around here. A lesson like this would make sense because you're not in the room with me trying to do it. So anyways, the hypotenuse is going to go boom in there, right? So 15, better my smartphone right now. It's going to mess with me. So 15 has to go there. That's your, make sure to anchor that in. It's where it needs to be. And the other ones just go in the other spots. So the 9 and the W can go in either spot there. We're just going to solve W. Okay. So the 9 squared, of course, is 81. So we're going to have 81 plus W squared. 15 squared is 225. Last time I checked, but we can just, it's not something you have to memorize. So you're like 15 times 15, you get your 225. Right. And so for solving here, again, pause and play as you wish, to try yourself and get help as needed. But you're going to solve for W squared, first of all, by getting rid of the 81. Just subtracting on both sides. Anyone wants help with solving equations, by all means, ask and I can help with that some more too. 225, take away the 81, gives us 134. And so we take the root, both sides. I'm not going to bother trying to plus and bonus thing anymore here, thinking, because version. I should always say it though, because people tend to forget there's actually 2 possible answers there. Just in this case, only 1 possible answer for the length of a triangle side. So with W, the double check if I had units on this last one. It's something for you to do as well, right? There was units in this question. And so as part of your question, you might say, therefore, it's 6.3 centimeters, right? Or just this centimeters would be fine for this type of thing. Whereas in this question, prompt me to think about it because there's no units in this one. So for some reason, my attention was drawn to that. And went back, prompted me to go back and check the other one. So anyways, Pythagorean theorem. Hopefully you've seen it before. Same idea here, solving for a side that's not the hypotenuse. So obviously the 12 is going to have to go into the spot. I thought I had one of those blanks here ready to go. But that hypotenuse is going to go in, right? And just get the job done. All for the missing piece. You might have seen as well some nice little puzzles in the past, so if you were to cut those pieces up, you can like jigsaw puzzle them in to the other side. And so it actually ends up being like that. If you wanted to print these out from the lesson and try for yourself, it actually be pretty tricky. I've seen them made out of like wooden puzzles. There's another template for another version of one. Here's a picture of students that have pieced it together. This is one that's kind of weird. It's like, it looks like it's almost solved, but really it's one on the bottom right. Anyways, lots of just ways that you can refresh or kind of just get a little bit extra experience with the Pythagorean theorem. If you want extra practice beyond the ones I gave you, there's a whole bunch here. Some of these are just focused on which one's the hypotenuse. Some are just focused on like, what the areas would add up to. So you just add the 25 and the 25 and 144, to get that one and so on. Right? But down here we have the ones we're just take a quick review of course, where you're solving for missing side. Some application style questions where not necessarily given a triangle directly, but a guy that can say, okay, well, wait, 90-degree here, and so I've got a, I didn't watch it thoroughly enough to decide whether that's exactly what we're going to do, but that is the kind of thing you want to do. You want to be able to visualize a triangle. So I would say just give those a try. These are extra ones, like I said, for practice, but the ones I have up here, there was one of the application style where you have a material for a guy wire for a pole, right? You want to know how much wire you need here for this pole. And, it just kind of puts it in an application. You can see what you can actually use this formula for. So they just basically get back into the triangle, plug the side, see, it's that hypotenuse. So of course, I don't see the spot. It's all by itself. Notice that my formula, our work certainly could be completely mirror image, right? So the hypotenuse could go on this side, in which case the other stuff goes on the other side, and you just solve, and you're just subtracting that's an equation if necessary, and so on. Okay, so don't let that mess it up. I think that's about it for this one. If you have any questions, by all means, message me and all that good stuff. Hope it works for you.